Hello friends, welcome back to the bench. Today we're gonna unlock this Surface Pro, Microsoft Surface Pro 4. The model is 1724 with locked BIOS. This one I got from a school. I bought it broken, 20 bucks on eBay with shipping. I bought five of these for 100 bucks. And all of them are BIOS locked. Now, BIOS lock is actually not a big issue on these devices, and that's actually shout out to Microsoft. There's no pairing, so you can all you need is some BIOS programmer. I'm using this one. It's very cheap. I don't remember how much they are, but they're like very affordable, and they come with the little converters, so you can either use the clips to attach to the BIOS chip without desoldering it, or desolder it as I'm gonna do it, and solder it onto this board, connect it, and upload or reflash the BIOS, which will not have password on it. The reason we can't use the clips is because the BIOS chip is actually in a very awkward position, and I can actually show it to you. The BIOS chip is over here, right here, this chip. So there's just no way to attach because it's too close to the shield. So we need to desolder the chip and reflash it, solder it back on, and that will remove the password. The only hard part of it is taking out the screen. Unfortunately, for any repair in this device, the screen needs to come off. This one is, I don't know if that's visible, but this one is cracked over here. Yeah, you can kind of see it, yeah. So there's only one crack, so it is possible to take off the screen without damaging it any further. Just keeping this one crack. There's actually one more over here. I can feel it with my nail. So possibility is that the screen will come in pieces. The procedure is actually pretty simple, but very time consuming. We need to heat it up and pry it. I use this. This is metal, so I only use it on the screens that I know are broken. This one actually has a digitizer not functioning on this side of the screen. It functions on this side, but not on the what I call their screen over here. So either way, this screen is needs to be replaced. So I'm not going to worry about not damaging it. That's why I'm using this tool. If this was a job where we need to reattach the original screen, I would be using plastic. This and one of these little prying tools, but it needs to be very thin because if you put too much pressure on it, it'll break. However, when it gets warm, especially very warm, it's very flexible. It's actually surprisingly flexible when it's warm. So let's just get to it. I'm gonna also maybe use this one, but this one's very handy. Now, how I like to do it is to look at the screen, right? Look at the opened device, because at the top over here, you have a lot more adhesive. At the bottom, a lot less. But at the bottom, you don't have to worry about damaging anything. You can push the tool pretty deep. At the top, you don't want to damage the camera. there's a flex cable over here, which is very easy to damage. This one, I think it's for proximity sensor or light sensor over here. I'm not sure, but it's if you work with metal, it's very easy to damage these. Luckily, I have plenty of spare parts for these, so I'm not gonna worry too much about it. But I'm still gonna try to be careful. All right, let's get to it. All right, and now quick consideration over here. I don't know that for a fact, but I've heard that these chips are pretty fragile when you heat them up too quickly. So I basically treat them like glass. So I'm blowing with 370 at 80 liters per minute. That is not enough to dislodge it, right? We can desolder it on this setting because there's a big ground plane. I'll show you in a second as soon as I take the chip off, but there's a big ground plane over here. That's why there's no way to do it with this airspeed and this temperature. But I'm just heating the board, heating the chip, heating everything around it. And once I'm satisfied, meaning once everything around here is hot, then I switch to max airspeed and 450. And the chip should just fall off, like so. Here's the ground point. Now I put the chip next to it. I don't take it out of the board. I don't take it off the board, so it cools down quickly. Now, let's put it on the converter. Let's get a little flux going. Oh no, 80 liters, that's enough because I have let it solder on the pins over here, and there's no ground plane. So this should set very quickly. Oh, it's sitting there. Oh, it was sitting there. Goodness. Okay, cut the ground plane. I shouldn't have touched it. Mm. Oh, okay, the trick of this is when your hands are not shaky. I guess too much coffee today. When your hands are not shaky, the chip needs to sit in the very middle. Otherwise, the ground plane is going to catch to one of the pins. That's why it either wants to jump this way or this way. So normally my hands are not this shaky, and I don't know, it's usually a little easier than here. But now the question is whether we're gonna read the chip. So the direction how it's supposed to sit. Find the CS. Where's the CS? Here. There is a CS pin. All right, so CS goes here on this side. So now I need to find CS as the first pin. Pin number 1. Did I do it right? Yes. So pin number 1 over here, and it goes to here. Yeah. It's hard to say when the chip is soldered on, but yeah, this should be the orientation. And if not, you can just flip it. All right. Let's see if the chip is going to be detected now. Chip not responding. Let's resolder it, because this is likely the soldering issue based on how much struggle there was trying to solder it. Okay, now the chip is detected, so it was a soldering issue. It comes with no surprise. Oh, what is curious over here? Well, you can see my screen, maybe. Yeah, it detects 3 chips, right? I don't know why it does that. This is 3.3 volt, because this programmer only handles 5 and 3.3 volts. So some BIOS chips are 1.8 volts, so don't connect it to this programmer. And now normally I would download the contents of the chip just to be sure, and then reflash new one. But I know this works because I've done it before, so I'm just gonna erase the chip. It's erased. And now I already opened the Surface 4 1724 binary. So let's program it with verification. Program and verify. Start programming, and that will take a while. Meanwhile, I will prep the board. So normally when you do it, you know, you have like tons of these to do. Then you probably just reuse it. Just put the chip back, heat it up, and it should work. I will remove the lead-free solder and replace it with leaded. That will make soldering a lot easier. And it's, I don't know, it's a good practice in my view, but it's absolutely not necessary, or at least not as far as I know. I've seen many people just, you know, taking those chips off and putting them back on the same solder, and it works. And it probably would, but I prefer to do it well. And by do it well, I mean, you know, let me call it this way. I have time. But if you do it as a business, then you probably don't have time to do it. So you would probably just put the new chip on it, and that's probably just fine. It's a bit too much solder for my taste. Continue yourself. Okay, now that we have leaded solder, soldering will be a lot easier. Now let's get the chip back from programming. Okay, execution time 2 minutes 47 seconds. Now let's put it back on. Start the device and see if it's gonna explode. It shouldn't. Now, if you're like me and you didn't remember where the dot was, right? Because that's what I did the first time. Oh, come on. Okay. Oh, are you kidding me? Oh, lucky. That was lucky. Um, okay, where's the dot? The dot is here. Dot indicates chip select, CS pin. So if you go to schematics, CS is over here on this resistor. That's how I found it, because I didn't remember which side it was facing. Now, soldering back on the board is a lot easier than on that little programmer, because we have a ground plane. So the ground plane is going to catch the chip. So even if your hands are shaky like mine, it should still be a lot easier than soldering it on the programmer. Okay. Now, as you can see, I don't push it down. I just let it fall into place, and we have like big solder balls here, because there was a bit too much solder. So if I pushed it, all the excess would have flown out, and then you would have to remove it with a soldering iron. But that's fine. Let's Let it cool down enough so you can touch it with your finger and not get burned before we put IPA on it, because IPA will drastically cool it down. And as I said before, I heard these chips are fragile. No worries though, because these are available everywhere, like on eBay, AliExpress, you know, in bulk. And I do believe Mauser carries those chips as well. These are standard SPI memory chips, right? There's nothing special about them. They're also not paired to the board, so you can freely replace it with a new one, and everything should work. Honestly, the hardest part of this job is taking the screen off, especially if you want to keep the screen that you took off. In my case, I didn't worry about damaging it, although I did try to do it without any further damage to it. And I actually did a little bit. So if that was the screen that I was taking off to be reused, it would not be viable to be reused anymore. And the reason I pushed the knife a bit too far over here. So there's a little blemish here, over here, and over here, right? And over here. Probably not everything is visible on the camera, but trust me, this screen is messed up either way. But our BIOS chip is here. So now, when we turn it on, I'm not even going to connect the digitizer because we don't need it, because it doesn't work anyways. As you connect the screen and turn on the device, it will do some magic behind the scenes. I actually am going to connect the digitizer because I'm not sure whether this is digitizer or not, but I'm pretty sure it is. It's going to do some magic, so don't be alarmed when it's not turning on immediately. And we're going to go into BIOS anyway. Okay, now it should be turning on, right? There's nothing on the screen. And it should take a second before it actually boots up. There we go. Now, oh, it's rebooting. Yeah, so it booted. Now it's rebooting. And it should do it at least once. There. Now let's try to get to the BIOS. Now it's loading Windows, but that's fine. Let's see. Getting devices ready, getting ready. So yeah, it's treating the motherboard as it's a new motherboard, as we just replaced the motherboard. Normally, you probably wouldn't just boot to the Windows that was installed on the system. And so this is kind of a fringe case in this case. I'm not sure what's going to happen. It did reboot again. I'm going to hold the volume up button this time, because I just want to get into the BIOS and confirm that we don't have password. There you go. No password. Let's see, the touch doesn't work anywhere. You can see the blemish from where my knife went a bit too far. But no BIOS, no BIOS password. So this is actually really awesome that Microsoft did that, or that Microsoft didn't tie that chip to the rest of the board unlike Apple does, and maybe newer models it do have that chip somehow paired to the rest of the device, or the BIOS is encrypted, or some anti-repair measures. In this case, well, the repair, it's not really a repair because we're just removing the password from password protected device. And this is a service that I offer. However, be aware that I will ask you why you need this service. Because one way this could be abused is when you steal the device and the device is protected, and you just want to resell the device, or I don't know, get into, I don't know, whatever you might need to do, which is malicious. I don't want to take part in that. However, this device was refurbished. It came with the password. I bought it as broken device, and there's not much I can do with it if the password, if the BIOS is passworded, because then I cannot boot from external drive, and the system installed over here belongs to the student that was using this device. One of them, I actually get already logged into the system. When I turned it on, I was already logged in, which was very weird. And there was someone was literally in the middle of the work. The spreadsheet was opened, and like weird. It shouldn't have done that. It should present me with the login screen, and I shouldn't be able to do that. So that's kind of a weird case, some kind of fluke in the device. But I don't have the password to this user, so I can only be presented with the login screen. So I want to wipe it out, but I can't wipe it out if there's a password on the BIOS. Now there isn't, so the board is perfectly fine now. The device is ready for a new screen, perhaps larger SSD, because this one's 128. Maybe we can just put half a terabyte, or 256 gigs, just to make it better. New screen, probably new battery. Well, before, oh, you see, it probably needs a new battery. But other than that, this will be a perfectly working device. If you're interested in this service, I do offer it. Feel free to reach out. You can reach out through the comments, write me an email, submit the ticket at blackhorserepairs.com, or email me at blackhorserepairs@gmail.com, or just write a comment. That's always appreciated. In either case, the device is ready to be used, except it needs a new screen. All right, that is the BIOS reset on Microsoft Surface Pro 4 1724. Thank you guys very much for watching, and I'll see you in the next one.